चलो. So today we are studying dynamics of particle. Dynamics of particle. Okay. मतलब till now we studied equilibrium by using free body diagram. We found upward force equal downward force. This side force equal this side force. बोल के we done. Okay. Now we are doing equilibrium. मतलब dynamics of particle. Dynamics means the object starting in motion. When the object is in motion, there is a force, there is a acceleration. Everything will be there, right? So we are seeing that how to tackle this. सो आपको क्या करने का, सिंपली वी आर यूजिंग न्यूटन सेकंड लॉ एंड वी आर सॉल्विंग. कौन सा स्पेशल केस मालूम है ना, एफ नेट इक्वल टू एम ए बोल के लगा ना, ये यूज करके वी आर सॉल्विंग द क्वेश्चंस. ये वाला क्वेश्चन मतलब सी सपोज मान लो हाउ टू अप्लाई. देखो सपोज मान लो यू हैव मास एम इज देयर. ओके, मास एम इज देयर. आई एम अप्लाइंग ए फोर्स F1 force. Definitely when there is a mass, when there is a force, definitely there is acceleration. So how to find how to apply the force formula? How to find acceleration in this case में? Tell me. Example I'm giving. How to find acceleration? Simply आपको net force. देखो इस mass के ऊपर only one force is acting. Only one force is acting. That is F1. So how to apply? F1 is equal to mass into acceleration. Here mass is 1 only. Mass m is m only, and a is a only. This is the answer. So from this a is equal to F1 by m. So how to find acceleration means simply net force equal to ma. And one thing you have to understand, that acceleration के direction में we should take positive force. Very important. Acceleration direction में the force should be positive. Okay, suppose मान लो you have two forces, F1 F2. Okay, the body is moving with this acceleration. Then कैसे यूज करेगा? How to use net force equal to ma. So net force क्या डालूं? F1 minus F2, F2 minus F1. Which one we have to use? Acceleration direction में we should take as positive. So F1 minus F2 is equal to mass into acceleration. Therefore acceleration पूछेगा तो F1 minus F2 by m. So this is the method you have to follow for solving the numericals. Okay. So confuse नहीं होने का, wherever acceleration body is going, उसी direction का force we should take as positive. That's why plus F1 where out. And opposite direction, acceleration का opposite direction force is all negative, equal ma use करेंगे. चलो no question solve करेंगे based on this all things. Copy it. Yeah. चलो now we are doing numericals based on this. Mano understood this one? Okay, right?
Yes, sir.
चलो हाँ करो. Suppose case 1 case 2 है given. एक inclined plane में one object is there, mass m. इसके ऊपर I am applying a force F. Okay. Similarly, second case में I am applying a force F at certain angle phi. Inclined plane. Both are the same inclined plane. He is telling to find what? He is telling to find the acceleration of the block and normal reaction offered by the block in the both the cases. Acceleration and normal reaction is asking. Now try. The object is not in equilibrium, it is moving. Okay, it is moving. Okay, so first one we are taking angle theta. Here mass m is there. I'm applying a force, exactly F. Now tell me what are the forces acting on this mass, then only we can apply acceleration. See, I'm applying a force like this, but the object is moving like this acceleration, right? I said inclined plane. Okay. Now tell me what are the forces acting on this? देखो horizontal and inclined angle is theta. So if I take the components, what is the component? याद है ना? Wherever theta is there, that direction we call as f cos theta, and the perpendicular component is f sin theta. And any other force acting on it? Any other force acting on it?
Normal.
What?
Normal force.
Normal force. Okay. Next.
mg cos theta.
So इस तरफ वाला कौन सा है? टेल में.
mg cos theta. mg
No,
sin
wrong.
theta.
mg sin theta. mg sin theta. Always, whenever incline comes, you should not take mg downwards. Always take mg sin theta, and this side is mg cos theta. Now apply net force equal to ma, because along the object is moving along this direction. Apply net force equal to ma. Net force कौन सा यूज करेंगे? Acceleration direction में you should take as positive. So f cos theta minus mg sin theta. देखो, this is the net force. Net force is equal to mass into acceleration, ma. Right? So from this you can find acceleration also. So acceleration कितना आएगा? Acceleration is f cos theta minus mg sin theta by m. This is acceleration. Got? Copy करते जाओ. Okay. Now normal reaction. See, vertically they are equilibrium or not? Vertically, whether the object is flying away, no, right? Vertically the object is stable, equilibrium hai. So that's why we have to equate upward force equal to downward force. Vertically it is equilibrium. Okay, why? The object is not flying away, object is moving like this. So vertical equilibrium, horizontal is moving, but vertically it is equilibrium. Therefore n upward, upward force equal to downward force. So f equal to f sin theta plus mg cos theta. Khatam. This is a normal action, this is acceleration, first case. So all models में करो, understand, because JEE में क्वेश्चंस देने वाला हूँ आपको, पूरा ये आगे तो पक्का कर सकते हैं. नेक्स्ट. नाउ इसका सेकंड केस का फाइंड करेंगे. अगेन टेक द कंपोनेंट्स ऑफ दिस. सो व्हाट इज द कंपोनेंट? wherever phi is there, the direction f cos phi, and उसका perpendicular component will be f sin phi. Okay, and normal reaction is also acting like this. And mg का again components, wherever inclined plane is there, I told you, इस तरफ वाला mg sin theta, and इस तरफ वाला mg cos theta, and acceleration is like this. Now apply the concept of net force equal to ma. Whenever object is moving with some acceleration, always use a net force equal to ma and solve. So net force कैसे आएगा? F acceleration direction we should take as positive, right? So f cos phi minus mg sin theta is equal to mass times of acceleration. So from this, A is equal to f cos phi minus mg sin theta by m. So you got acceleration. In both cases, we have to find acceleration and normal action. Normal action find करो. Since vertically there is equilibrium, upward force equal to downward force. So n plus f sin phi is equal to downwards is mg cos theta. The numbers they will give, you can find, right? 2 kg mass is sitting at 30 degrees angle. You can find acceleration. So but variables, in terms of variables we are doing. Okay, therefore n is equal to mg. So here n plus mg cos theta. So mg cos theta minus f sin phi. खत्म. नॉर्मल एक्शन पे आ गया, एक्सेलेरेशन पे आ गया in both the cases. Got a? Yes.
Yes, sir.
No. Copied? आ गया. हाँ. Now next question जाएंगे. So आपको इनिशियली थोड़ा डिफिकल्ट जैसे लगेगा बड़ा, बट नंबर्स दिया तो आपको इजी है. 2 kg 30 degrees easily you can solve, and this is suppose 60 degrees, so you can find easily. Numbers will be there, means easy हो जाएगा. चलो नेक्स्ट क्वेश्चन करो. हाँ करो.
Sir, can you go back for 1 minute? 1 minute.
चलो
Yes, sir, done.
हो गया। मैं करो। Two blocks of masses m1 m2 are placed side by side. They place side by side. I am applying a force F. Okay. As shown in figure. A horizontal force is applied on the block. A force is applied on the block. Then it's telling find the acceleration of each block. Each block का acceleration चाहिए. And find the normal reaction between the two blocks. Okay. See, whenever the blocks are in motion, matlab, whenever contact, blocks are in contact, definitely when you apply a force, both will have same acceleration. याद रखो, both will have same acceleration. So A, either B, we have to apply A. Okay. Now he's asking find the acceleration of each block. Each block acceleration. मतलब A find किया तो बस है ना. So apply, draw the free bird diagram for each and everything. And
So
solve.
won't it just be F by M1 plus M2?
Yeah, that we'll see. First थोड़ा free bird diagram draw करके करो, then we'll see. Okay, acceleration of the each block and find normal action between two blocks. Okay, so आपको क्या है? देखो, this is applying a normal action like this, n, and at the same instant में this also will apply a normal action in the opposite direction, n only. And you tell me this F is applying for both or m1? F is applying for force F is applying for both massa, only one massa.
So only for M1.
Only for m1. Then why it is moving? Because of normal action is moving, right? Now apply net force. M1 ka free body diagram I am drawing. This is M1. I am applying a force F like this, and this is normal action, and this is acceleration, and M1 ka. So net force equal to m lago. So F, because acceleration direction positive, right? So F minus n is equal to m1a. First equation. Now similarly m2 का equation क्या आएगा? So m2 के ऊपर only one force is acting, n. So if I draw the free body diagram m2 का, so it is only one force is acting, n, and acceleration is a. So net force कौन सा है? n is equal to m2a. So then if I substitute this n value here in the first equation में, substitute 2 in 1. So क्या होगा? Tell me. F minus m2a is equal to m1a. Therefore, F is equal to m1 plus m2 into a. Therefore, a is equal to F by m1 plus m2. A equal to F by m1 plus m2. This is the acceleration of the block. Now substitute this in this. N is equal to how much? m2 into F by m1 plus m2. This is the normal action. Understood? देखो, we have a shortcut to find acceleration. Okay, shortcut is there to find acceleration. Easy है, वो use करेंगे. So shortcut क्या है? Two masses को we should treat as one system. Two
Yeah, sir.
masses
It'll be the net force divided by. Sir. Yeah, sir. Assert or that shortcut.
This is system का मान लो. System मान लो. System का मान तो net force से acceleration का formula always use net force by net mass. Okay. Net force is how much? इसके इस system के ऊपर only one force is acting. So F by net mass, total mass is m1 plus m2. देखो डायरेक्ट आ गया. F by m1 plus m2. Net force by net mass always we are using, but if both object is moving with same acceleration, अगर different acceleration में गया, shortcut you can't apply. Shortcut गया तो answer wrong हो जाएगा. That's why method भी सीखो, ये भी सीखो. If the objects are moving with different acceleration, that time net force by net mass नहीं चलेगा. Only when they are both blocks are moving in the same acceleration, then only use this all things. Okay. And definitely normal reaction के लिए definitely again free body diagram use करना पड़ेगा. Normal reaction के लिए again we have to use free body diagram. Copied?
Yeah, sir. Done.
Yeah. Let her do. नेक्स्ट हाँ कर ट्राई करो अभी थोड़ा क्या तो जेई में क्वेश्चंस करने वाले देन दैट टाइम वी शुड बी वेरी क्लियर two blocks of masses this much are placed in contact with the smooth horizontal surface. A horizontal force 6 newtons is applied on 1 kg here, and here I'm applying 2 kg. Two different cases. Okay. Find the force of interaction between the blocks. Force of interaction between the blocks means normal action find karo. Try to apply the concept and try karo. Normal action apply karo. So either first case में क्या होगा? This block will apply normal action on this one n1, and this will apply normal action n1 like this. And since I am applying a force, there is a smooth surface. Acceleration is both are same because attached, right? So no block का acceleration same. Now for 2 kg, I want a normal action, right? You tell me for 2 kg, which one is easy we have to solve? 1 kg का use करे तो easy है और 2 kg है. 2 kg use किया तो अच्छे easy है ना?
So this is the answer 3.
N1 is equal to mass into acceleration, right? 2 times of A. This is the first for 2 kg. If I apply the freeboard diagram, we'll get N1 equal to 2A. And acceleration कैसा आएगा? Shortcut क्या है? Acceleration is you should treat this as system, one system. So net force by net mass. Net mass कितना है? 2 plus 1 is 3. So it is 2 meters per second square is acceleration. Then substitute here. N1 is equal to 4, 2 into 2, 4, right? Meters. 4 newtons is acting on this first one. He's asking force of interaction, right? Force of interaction between two bodies means nothing but normal action. Okay. Now for second one, find karo. So this is applying a force on this N2, and same instant this is also applying a force on this N2.
So the
So
first
acceleration, kitna?
the first one normal reaction is 8. Second one is 2.
First one is wrong. First one is 4. Right? Why? Net force by net mass is how much? Net force is 6.
Sorry. So
Okay.
my subtraction. And
Now
then second.
iska, N2 is equal to net force equal to MA. MA means 1 into A. Okay. And A, you know already. Net force by same, right? Net force by net mass. It is 2, right? If I substitute N2 is equal to 1 into 2 is
No, but
2
how will
newton.
N2 be 1A, sir? Isn't there 6 newtons acting on the 1 kg block?
No, 6 newtons is not acting on 1
No, sir,
kg
for the
block.
first.
1 kg block में act हो रहा है, but I am using for 2 kg का directly. Easy हो जाएगा.
So, but didn't they?
See, force of interaction means they both are same only.
Never mind. Sir, so if we have to find the force, I mean, if we have to find the normal for 1 kg, what will it be?
हाँ 1 सेम है, सेम आएगा भाई. देखो if you apply here concept में net force कौन सा आएगा? Tell me. 6 minus n1 is equal to 1a. So if I substitute, we'll get n1 same. Okay. So that's why which are easy, that one I choose and I solve.
So I got N1 as 4 then.
N1 is 4, yeah.
Oh.
N1 is 4, N2 is 2. Understanding everybody? Don't know on the video. Okay. Chalo. No solve karo. Chalo. This is simple way. Karo. Find the force of interaction between the bodies. Same as shown. Force of interaction is nothing but normal action we have to find. So normal action draw करेंगे. This is applying a normal action N1 and this is applying a normal action N1. Similarly, this body is applying a normal action N2 and this is applying a body N2. And not right. Find interaction. मतलब N1 N2 find करने का. That's it. Find करो. Whichever easy you can use. Since both are in all are contact में, all are having acceleration same. A. So here whether we use f by try करो. So इसका मैं क्या करूंगा, इसका कंपोनेंट निकाल लूंगा. What is the component of f along this one is f cos theta. Okay. Now acceleration कैसे आएगा? Net force पे net mass. If I treat this as one system, f cos theta.
You have theta in the answer.
Oh, yeah.
So then it will be N1 will be F cos theta minus F M3 by M3 plus M2 plus N1. And then N2 will be F cos theta minus F M3 by M3 plus M2 plus N1 minus M2A.
Okay, देखेंगे. देखो acceleration is net force by net mass. Net force by net mass is m1 plus m2 plus m3. ये तो आ गया. Now is asking interaction, right? n1. ये last one ले रहा हूँ मैं. What is the simple equation? n1 is equal to m1a. खत्म. n1 you got as m1 f cos theta. एक ही जगह में f cos theta by m1 plus m2 plus m3. This is a normal action simply. Okay. Now n2 को कौन सा लेंगे? Whichever easy you can. n1 तो आ गया ना, मालूम है ना. So आपको ये ले लेंगे. So n2, what is the equation for m2? Mass m2 का equation क्या होगा? n2 minus n1. n2 minus n1 is equal to mass times of acceleration. If I substitute n1 के जगह में substitute किया तो n2, मैं इस तरफ लेके जा रहा हूँ, m2a minus n1 will be plus n1, right? So plus m1 f cos theta by m1 plus m2 plus m3. So if I take कुछ common है ना, acceleration के जगह में again if I use this one m2 into f cos theta by m1 plus m2 plus m3, इसके acceleration की जगह में डाल रहा हूँ, plus m1 f cos theta by m1 plus m2 plus m3. खत्म. Values if you know you can solve, but this is a thing. Understood? Doing a? Yeah. चलो. Please understood it वाला? Next. Copying.
Sir, once can you zoom in on the diagram?
M3, M2, M1.
Okay, sir. Well, thank you.
कि
Sir,
माइनस
how is
वाले प्रश्न नहीं है
equal to
और समथिंग
M1
समथिंग. हाँ
Sir, how is N1 equal to N?
देखो पर M1 का फ्री वर्ड.
No, sir, my N1 is N2 and my
हाँ मुझे ऐसे रंग गया
sir is
समथिंग.
ulta.
ओके.
No, sir, I told
हाँ
ulta. I took
ओके
from this.
ओके 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 ओके. चलो अनुष्का चलो चलो नेक्स्ट. हाँ करो. देखो देयर इज ए कैपिटल M is there and small m is there. दो ही मास है.
Problem.
हाँ
So the water bottle leaked on my page. Now what should I do?
ये नेक्स्ट पेज पे जाओ.
No, sir, the whole back part is wet.
नहीं तो दूसरा पेज में लिख के बाद में यू कैन स्टिक विद इट. Capital M, small m is moving with acceleration a. Okay. Now it's telling to find to place in platform moves up with the पूरा platform पूरा ऊपर जा रहा है acceleration पे. Find the normal action between the blocks. Between the blocks में normal action चाहिए. And normal action between the block exited on the platform. मतलब platform में कितना exit किया, that also I want. Two normal actions I'm asking. Okay. So इसका normal action on the block exited by platform. कितना a platform कितना exit कर रहा है normal action. And इसके बीच में normal action क्या बोलूं? This is applying a normal action N1 and this is also applying the same n1, and this is n2 on m के ऊपर लगा रहे ना, m के ऊपर लगा रहे ना m2. is asking n1 n2 के values asking. करो in अभी तक all concepts में using net force equal to ma. These all things if you know then only constant motion होने दो, spring force होने दो, सब कुछ आएगा, नहीं तो गए काम से.
Sir, all my yesterday's notes are full weight. I mean, last class notes are full weight.
ओके बाजू में रख के पेपर में करो, व्हाइट पेपर, पिन पेपर में करो, करके दूसरा बुक ले लो ना तो. So now if I use the equation of small m and capital M ka anything, you can find the value. Tell me what are the forces acting on it. A normal action, okay, this is downwards is mg and other one is ab small mg. For small m if I use, what is the equation? Acceleration direction mein the force is positive, right?
So n minus mg is equal to capital M into
first small m का apply, I am applying small m का. Small m का क्या होगा? n1 minus mg is equal to small m into acceleration.
Yeah.
So therefore n1 ठीक है, first equation. Now second equation में क्या है? First capital M का downwards n1 है and mg भी है. So
we have to add them.
ऊपर जाने समय ऊपर जाने में क्या होगा? What is the force acting? n2, right?
Yeah.
So n2 minus n1 minus capital mg is equal to ma, capital Ma, right?
So but shouldn't you add the small mg also?
No, I told you gravitational force will be acting only with respect to bodies only. It will not fall on this. Okay, then which one is falling? n1 take care of that one. n1 will take care of this small mg. Okay, so n1 we are using, again we should not use that one. Now use karo. From this n1 is equal to how much? From first equation में से n1 is equal to mg plus ma. So n1 के जगह में I am substituting this. So n2 minus mg minus ma minus mg, capital mg is equal to ma. So when I bring this side, n2 is equal to m times of g plus a plus m times of g plus a. This is n2. Now if I substitute this, you will get the n1. n1 में n1 तो आ गया ना, n1 this one. So n1 is equal to कितना आएगा? m times of g plus a. This is n1. So n1 n2 values आ गया. In terms of variables में we are doing numericals with, तो आपको steps will be reduced. It will be easy. Okay. Here भी acceleration कैसा आएगा? देखो दो both blocks are having acceleration, same acceleration, right? So net force by net mass. So net force कैसा यूज करेगा? देखो acceleration करने के लिए इसके ऊपर जो net force कुछ act हो रहा है नहीं है ना? mg we can use, mg का use. देखो I'll show in pulley में roll में you will understand क्या बोल के. But ये मतलब understood clear? Okay, copy da.
Oh yeah, sir. In that
Tell.
yeah, sir. In that momentum question, like when we were doing momentum, you gave a question, right? One second. One second. I wrote it. Yeah, so that 2 root of p by k. That same question came for our exam today.
Okay. Direct लिख दिया, you will not do right, direct टिक कर देना.
Yeah, so directly I tick.
Yeah. चलो next. Okay, apparent weight. See, what do you meaning of apparent weight? I think apparent weight means
Sir, not real weight.
Okay, you tell me, weighing machine measures what? ये तो स्कूल में पूछा होगा, कॉलेज में भी. Weighing machine measures. हाँ बोलो कृष्ण.
Sir,
Weight, no. Weighing machine does not measures weight. Okay, वो एक स्पेशल कंडीशन में weight measure करेगा. That is when the object is at rest, then only it will measures weight. But actual answer, perfect answer, 100% answer कौन सा है मालूम है? weighing machine measures normal reaction. That is a perfect answer. Okay, because सेम वेइंग मशीन रख के आप चाहे तो एक्सपेरिमेंट करो, सेम वेइंग मशीन में लिफ्ट के अंदर में रख के यू स्टैंड ऑन दैट एंड यू प्रेस अपवर्ड्स अपर फ्लोर में, अपर फ्लोर जाने समय आपका वेट बढ़ता जाएगा. यू चेक वेइंग मशीन लगा के, मान लो यूर 45 kgs. ओके, व्हेन यू आर गोइंग अपवर्ड्स, when you're going upwards it will showing 47 ऐसा दिखेगा. Similarly same way when you're going downwards your weight is decreased. So suppose you want to show the weight lesser, so you say, you tell your friends that going downwards, at that time show weight is decreased. So that time why that same weight, original weight name measure नहीं करे ना, same weighing machine, that means normal reaction it measures. Okay, that weight is nothing but apparent weight. We will go see. देखो, apparent weight is a normal force exerted by the surface, like floor on the elevator or weighing scale of an object. So the apparent weight is a normal force exerted by the surface. Surface ने कितना exert किया, normal action, that is the apparent weight. And note, apparent weight is equal to normal force, that is equal to reading of weighing machine. So reading of weighing machine is always calculate the normal force only. I'll show example where the weight will be greater or lesser, we can see. आप चेक करो, कभी लिफ्ट में जाने समय लगाओ नीचे, चेक करो, डाउनवर्ड्स में आपको वेट कम होता जाएगा.
Yeah, sir, done.
Okay, चलो, एक करो. A man of mass m stands on a weighing machine in an elevator. Okay, एक elevator में the man is standing on the weighing machine. The weighing machine. Standing. Okay, the calculate the reading of the weighing machine. If इसका mass है capital M, right? इसका mass है capital M. The accelerating upwards with the acceleration A. Tell me, if the lift is going with acceleration A, he is asking what is the reading of the weighing machine. Reading of the weighing machine means you have to calculate normal action. Normal action. Okay. So we know Newton's second law say whenever the object is accelerating. So what is the force acting on it? Downwards is mg and upwards is normal action. Now apply net force equal to ma. Acceleration direction में you should take as positive, right? So net force क्या होगा? N minus mg is equal to ma. So therefore normal reaction is equal to m times of g plus a. Is the first one?
Yeah.
Right. Now second one karo. If
G
same
m into g minus a.
Same weighing machine, same person, if is going downwards with acceleration, so mg and normal action. So इसमें क्या होगा? mg net force क्या है? mg minus n is equal to ma. So therefore n is equal to m times of g minus a. The third condition में, if the object is at rest, then कैसे करेगा? If the object is not moving up and down, is reading machine, don't tell me इसके ऊपर mg and ये वाला normal action. Since the object is at rest, upward force equal to downward force, so n equal to mg, which is weight here, right? That's why the person when it is stationary, the weighing machine measures weight, but the person, same person, if it is accelerating, it is not measuring. देखो weight is mg, इसमें क्या हो रहा है? mg plus ma बढ़ता जा रहा है weight, इसमें क्या हो रहा है? mg minus ma घटता जा रहा है. Okay, so that's why आपको रिमेम्बर करने का, weighing machine measures normal reaction. ये स्कूल में बोला होगा कंपल्सरी, राइट? weighing machine measures normal reaction बोल के बोला?
No, sir.
बोलेगा, you did not listen, maybe that time you are playing somewhere. Okay.
So they didn't tell it, but then that's
So they didn't even do apparent weight only for us.
how
Okay,
they
okay.
told to solve the sums.
Chalo, no problem. Weighing machine measures normal action. Okay. Then now we'll go problems based on connecting strings wala. All models करने वाले connecting strings wala. हाँ चलो. Suppose you have mass small m and 3m.
So wait, can you go back? So what was the third point?
Third point, when the object is at rest,
Okay.
is not accelerating. That time upward force equal to downward force because it is in equilibrium. So that time if you equate n equal to mg, that is nothing but weight. It's called true weight, right? True weight. That's why when we are standing alone, that is a weight, correct weight. But when we are moving in a lift, that is not weight. Apparent weight बोलते हैं. जो दिख रहा है ना, apparent weight बोलते हैं. चलो. Now एक करो. Suppose you have mass m and 3m. They connected with strings. I am pulling with 2f force. Okay, here I am pulling with f force. So at that time, it's telling to find tension in the string and acceleration of the blocks. Easy. Tension in the string and acceleration of the block. Acceleration आपको easy, right? Acceleration कैसा आएगा? Tell me. Net force by net mass. This is the formula. Net force upon net mass. Okay. Net force क्या है? It is accelerating in this direction, right? Right. Both are accelerating in this direction. So this is acting as one system. This is one system. Tell me net force कितना होगा? Anybody? Net force is 2f minus f. Okay. So 2f minus f net force. So f by net mass. M plus 3m is 4m. So this is the acceleration. Okay. Now he's asking tension in the string. Tension in the string. So you know tension का कैसा apply करने का? Tension is away from the point. So here T and this also T. And this is 2f. 2f is nothing but tension only. There 2f and tension is same. Now apply acceleration. Now apply each
So
block acceleration.
5f by 4.
5f by 4. Very good. So net force equal to ma. So T minus f is equal to ma. So T is equal to m into a के जगह में f by 4m plus f. Right? Ma plus so or we will write the equation there.
Sir, oh no mind.
Atal. Is
No,
second
sir,
question क्या होगा?
No, the net force will be f only, right? Because of 2f minus f.
2f minus f. Okay. And इसमें equation apply करो. 2f
So then we
2f
can use the
minus
first
t
equation only, no, sir.
equal to 3m.
3 first equation से नहीं आ रहा है ना? Again in terms of
So if you
mass में आ
substitute
रहा है ना?
acceleration, mass and mass will get cancelled.
Okay,
And
okay.
then
First equation में
you'll
आएगा.
get
So
in
T
terms of
minus
f.
f is equal to mass times of mf by 4m, right? Mm cancel. T is equal to 5f by 4, right? Yes, correct. So don't know it of second equation only. So it connected with strings है. Okay. Since we are using shortcut because both having same acceleration. अगर different acceleration we can't use the shortcut. आपको free body diagram draw करके ही solve करना पड़ेगा. चलो. करो. 4 kg, 2 kg, 1 kg. I'm applying a force 28 newtons. He's telling to find tension in each string and acceleration of the string.
So the acceleration is 4.
Acceleration is here, na? Net force per net mass. So 28 by 6, 7. 4 meters per second square. Now tension in each string. So this is T1. इसके respect में away from the point is T1. Sir A क्या होगा? T2. And इसके respect में away from the point T2. And A वाला तो 28 है. And all are moving with acceleration A. Because they are connected, right? वो solve करो.
So T2 is 16. No, wait. T1 is 16 and T2 is 24.
मानो करो, क्यों ना कर रहा है इसको?
That's what I'm thinking.
Net force equal to ma.
Won't the
Net,
acceleration in each string be 4 only?
4 only, because they're connected with the bodies, right? And pulling, right? All are moving with same acceleration. Okay. So net force equal to ma lago. T1 is equal to ma. 4 into a.
16.
So T1 is 16 newtons. And T2 wala kaun sa? You can use this or this anything. 2 kg
T2 will be
resistance.
T2 minus T1 is equal
T2
to
minus T1 is equal to 2a.
8.
So T2 is equal to
24.
8 plus 16. So T2 equal to 24.
Sir,
Okay.
how would you know if the acceleration is different?
Acceleration will be different, will be the, you know, एक body है, वो आप आगे आएगा. This body है. अगर ये I am applying a force F है. Okay. So ये slippery है, मतलब there is no friction. That time क्या होगा? Body ये वाला ऊपर जाएगा, ये वाला ये तो because अगर friction है तो it will start moving in the backward direction with different acceleration. At that time net force by net mass we can't use. Okay. You will see आगे questions आएगा ये सब. Understood? Pulley problem, very important problem. Okay, here m1 है, इधर m2 है. मान लो m2 is greater than m1. Okay, so ऐसा नीचे आएगा. पुल्ली मालूम है ना? पुल्ली, and इधर attached है. Okay, find the acceleration of the masses and tension in the rope. Find the acceleration of the masses and tension in the rope. देखो ये since m2 is greater than m1, acceleration नीचे आएगा. This will be acceleration is ऊपर. ये वाला डायरेक्ट फॉर्मूला मालूम है ना? ये वाला नहीं मालूम? डायरेक्ट सुशा? अरे అవునా, वेरी इंपॉर्टेंट वन दिस वाला. क्या है
Yes,
डायरेक्ट
sir.
है?
After gave. But I
हाँ
forgot
मेरे
formula.
कंपलसरी, वो तो अभी अभी डिराइव कर रहे हैं, बट वो फॉर्मूला हमेशा लर्न करना पड़ेगा. वेरी इंपॉर्टेंट, नहीं तो आपको बार बार प्रॉब्लम हो जाएगा. ओके, तो ये यूज
Sir,
करो.
isn't
देखते
it M1 plus M2 something something?
हैं. सी आधा कर रहे हैं.
So M1 plus M2 into G by
नो
sir, I
ऊपर
learned it today morning only, sir. I forgot.
हमारे लर्न करना पड़ेगा. इसका मेथड से करो, पहले लर्न करेंगे अब विदाउट दिस वन. ओके, देखो इसके ऊपर व्हाट आर द फोर्स एक्टिंग. आई वांट टू फाइंड एक्सेलरेशन, राइट? इसके ऊपर व्हाट आर द फोर्स एक्टिंग? वन इज m2g, ऊपर टेंशन t, राइट? ये सेम स्ट्रिंग है, टेंशन t है, एंड हियर m1g. नाउ अप्लाई टू इक्वेशन सेपरेटली. सो नेट फोर्स इक्वल टू ma. सो क्या करेंगे? m2g माइनस t इज इक्वल टू m2a. नेट फोर्स इक्वल टू ma. देखो एक्सेलरेशन डायरेक्शन में वी शुड टेक पॉजिटिव, राइट? हाँ, एंड फर्स्ट इक्वेशन क्या था इधर? इसका इक्वेशन t माइनस m1g इज इक्वल टू m1a, राइट? नेट फोर्स इक्वल टू ma. नाउ ऐड करो दो इक्वेशन को, फर्स्ट एंड सेकंड, सो दैट t विल बी कैंसिल, राइट? सो माइनस t प्लस t कैंसिल. m2 माइनस m1 इंटू g इज इक्वल टू m1 प्लस m2 इंटू a. Therefore acceleration का फॉर्मूला है m2 minus m1, you're telling plus, by m1 plus m2 times g. This is the formula you have to remember for pulley and two bodies. For pulley and two masses are connected, then use karo m2 minus m1 by m1 plus m2 into g. Suppose m1 is more, that time क्या करेंगे? m1 minus m2 by m1 plus m2 into g. Since here m2 is more, that's why m2 minus m1 by m1 plus m2 into g. Now similarly substitute this in one equation and find tension. देखते हैं टेंशन में. फर्स्ट इक्वेशन में सबट्रैक्ट कर लो, हो जाएगा. तो फर्स्ट इक्वेशन क्या था? टेंशन इज इक्वल टू m2g माइनस m2a. सो ए माइनस टी इधर लेके आया, m2g माइनस m2a. ए सबट्रैक्ट करो, t इज इक्वल टू m2g माइनस m2 इंटू a इज m2 minus m1 by m1 plus m2 into g. Okay, after solving this one, you'll get answer, that answer. I don't need of solving time waste karo. You have to use 2m1 m2 by m1 plus
Oh yeah, sir. Sir,
m2
give this
into
formula.
g.
Yeah.
वेरी इंपॉर्टेंट फॉर्मूला, ये दोनों आपको रिमेंबर करना पड़ेगा, मेथड से नहीं करने का अभी से यू हैव टू रिमेंबर दिस वन। फॉर्मूला पूछूंगा, पढ़ो, बैठ करो।
So we can remember the tension as average velocity like that, right?
कर सकते हैं बट हाँ, इन्हीं भी तक 2m1 m2 by m1 plus m2 into g and m2 minus m1 by m1 plus m2 into g। हाँ बोलो, प्रणव बोलो, व्हाट इज फॉर्मूला एक्सेलरेशन टेंशन?
m2 minus m1 by m1 plus m2 into g.
ओके, टेंशन फॉर्मूला कृष्णा, टेंशन फॉर्मूला इज 2
2m1 m2 by m1 plus m2 into g.
यस, कवर्ड। चलो नो करो, देखते हैं। फाइंड द एक्सेलरेशन बोथ द सिस्टम, केस 1 केस 2 में एक्सेलरेशन चाहिए, फाइंड एक्सेलरेशन।
Sir, wait. Sir, I have to.
क्या टेल में?
Sir, over here for the second case.
फर्स्ट केस हो गया,
we,
सेकंड केस में जा रहा है। ओके चलो, हाँ सेकंड केस में बोलो।
sir, do we take both the bodies का axis the same or can we choose the axis whichever one we want? Like,
सी, एक्सिस का विचेवर वन नहीं है, ऐसा नहीं है। आपको कंपोनेंट्स निकालने समय इंक्लाइन प्लेन में क्या किया हम लोग, एक्सिस का कैसा ले लिया, वी टुक एज
sir, we
एक्सिस
take, yeah, that is x and then this is y.
हाँ, उसके अकॉर्डिंगली ओनली वी गॉट हियर mg cos theta,
Yeah,
mg
sir.
sin theta, right?
Sir, but do we do the same thing for, sir, like we're taking the axis for this one as this, but we can't take the axis for this one as this, no, sir.
See, we are drawing free body diagram for different cases का free body diagram, इसका उसका संबंध नहीं है। आपको free body diagrams का यूज करके देखो, what are the forces acting on, tell me first of all इसके ऊपर। फर्स्ट सेकंड केस में जाएंगे, टेल इसके ऊपर what are the forces? Downwards is 2mg
2mg and then
2mg.
tension is upward and
P?
then acceleration is downward.
हाँ, एक्सेलरेशन डाउनवर्ड्स बिकॉज m ज्यादा है ना, इस तरफ
हाँ.
जाएगा। खत्म। नो इसका अभी, एंड इसका दूसरा फोर्स क्या है, एनी फोर्स एक्टिंग हियर?
Yeah, on the right.
mg
mg
sin
sin
theta,
Sin
And
theta
bottom
and
mg
then
cos.
mg cos
mg
theta.
cos theta। हाँ, सी,
and normal on the top.
हाँ नॉर्मल एक्शन, वर्टिकली इक्विलिब्रियम है ना, नॉर्मल एक्शन का जरूरत नहीं है इन दिस में, नो 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 नॉर्मल। फाइंड एक्सेलरेशन नो इन सेकंड केस में,
Sir,
सेम
but they're on the same pulley, no, sir. Like they're on the same.
सेम पुली है, आपको एक्सिस लेने से प्रॉब्लम नहीं है, वी कैन रोटेट। व्हाट इज मीनिंग ऑफ एक्सिस का रोटेशन किया तो क्या प्रॉब्लम है? आपको कंडीशन क्या है, एक्स एंड वाई शुड बी परपेंडिकुलर ऑलवेज, आप कैसे भी रोटेट करो। देखो इधर इसके रेस्पेक्ट में वी आर टेकिंग द एक्सिस एज एक्स एक्सिस एंड वाई एक्सिस एंड अकॉर्डिंगली वी रोट द
Okay.
कंपोनेंट्स। इसका रेस्पेक्ट में वी आर टेकिंग वर्टिकल है ना, वर्टिकल फ्रेम, वाई वाई एक्सिस ओनली आई एम टेकिंग। सो ऐसा नहीं तो, मतलब टेढ़ा नहीं, मतलब इधर टेढ़ा, इधर इधर वाई एक्सिस डिफरेंट है बोले तो नो प्रॉब्लम, चलता है। बट आपको ऐसे लेने का, सेपरेट सेपरेट फ्री बॉडी डायग्राम ड्रॉ कर रहे हैं ना, उसके अकॉर्डिंगली वी आर ड्राइंग। देखो, कैन वी अप्लाई शॉर्टकट हियर फॉर दिस वन? कैन वी अप्लाई शॉर्टकट?
Sir, won't it be t minus mg sin theta is equal to ma?
कितना?
T minus mg sin
नहीं
theta is
ठीक है,
equal to
टी निकल दो, टी नहीं है। देखो, वी कैन अप्लाई शॉर्टकट, कृष्णा हियर, कृष्णा कैन वी अप्लाई शॉर्टकट हियर इन इसमें, बिकॉज एक्सेलरेशन सेम है ना। सो क्या आप सोचा ऐसा, देखो देयर इज अ टेबल, इस ऐसे मैं हॉरिजॉन्टल लगा रहा हूँ, हॉरिजॉन्टल लगा रहा हूँ, दिस इज 2m, दिस इज m। ओके, इसके ऊपर व्हाट इज द फोर्स, mg sin theta is there, इसके ऊपर 2mg is there, right? So you can treat this as system and acceleration is like this, right? What is the net force, tell me? Acceleration is, net force is how much? इस सिस्टम के ऊपर नेट फोर्स क्या है, 2mg माइनस mg sin theta, नेट फोर्स समझ में आ रहा है? This side minus this side by net mass is 3m। So m can cancel. So A is equal to 2g minus g sin theta by 3m. 3 is answer. Head force. मतलब you can imagine that because both are having same acceleration. कभी भी both acceleration same है तो we can apply shortcut. So इसको भी इसको बोलो, tell me. इसको सीधा कर दो. क्या क्या एक्ट हो रहा है? इस तरफ वाला forces m2g and tension T, a tension T, and here we are assuming m2 is greater than m1. So therefore acceleration downwards है. इसका भी downwards and acceleration like this. हाँ ना shortcut अप्लाई कर सकते हैं. इधर तो कौन सा इंटरनल फोर्स हो गया. नेट फोर्स विल बी m2g by net mass will be m1 plus m2. if you apply for each and every block का अप्लाई करके सॉल्व किया तो भी सेम आएगा. तो मैं इसके तो पीछे कुछ फोर्स नहीं है, ये तो इंटरनल फोर्स है. हाँ टेल मी.
So in case 2 for the free body diagram of M,
हाँ
why isn't tension acting?
टेंशन एक्टिंग है ना. T सेम स्ट्रिंग है ना. टेंशन विल एक्टिंग कंपल्सरी.
But in the equation we never wrote T.
हाँ दैट ओनली. एक्सटर्नल फोर्स लिखने का, इंटरनल फोर्स नहीं लिखने का. एक्सटर्नल फोर्स वी शुड राइट. मतलब बाहर की तरफ वी आर टेकिंग. देखो आई टुक दिस वन राइट हियर. टेंशन इज एक्टिंग बट ये इंटरनल सिस्टम के अंदर है. अंदर का वी शुड नेवर टेक. कॉर्नर वाला लास्ट वाला वी शुड टेक. सो एक्सटर्नल फोर्स नेट फोर्स बाय नेट मास. ओके
Sir, but can't we write two equations and solve it simultaneously?
हाँ सॉल्व कर सकते हैं बट टाइम ज्यादा लगेगा. कभी भी देखो दैट इज स्टैंडर्ड मेथड. आपको 2 इक्वेशन सॉल्व करके, इवन पुली का ऑल्सो 2 इक्वेशन सॉल्व करके, वो स्टैंडर्ड मेथड. मतलब शॉर्टकट यूज करो ऑलवेज. पुली का हिसाब निकाल लो, खत्म. इजी. नेट फोर्स में नेट मास इजी हो जाएगा. ओके चलो. हाँ करेंगे. बोलेगा करेगा. मानो डोंट गेस. मार खाएगा करने का. अभी सम क्वेश्चंस किया तो सी इसके बाद वी हाउ सो सी वी कैन रिमूव दिस ऑल थिंग्स करके एटलीस्ट नंबर ऑफ क्वेश्चंस रिड्यूस करके आई कैन फिनिश द पोर्शन 3 क्लास में हो जाए, 2 क्लास में हो जाएगा पूरा. मतलब कर सकते हैं बट आपको लॉस हो गया. इसलिए ज्यादा क्वेश्चंस करो प्रॉपर वे में. उसका जेई में भी करो. देन विल गो फॉर ईच एंड एवरी टॉपिक. ओके चलो करो. नो हेल्प. यू ओनली डू एंड टेल द आंसर्स.
So options not there.
नो ऑप्शंस. आप ही बोलो.
Sir, can you please give?
Diagram not there.
अब डायग्राम नॉट गिवन. मैं क्या करूं. 2022 ऑप्शन सेल क्यों चाहे तो.
So they
Zero
should give no, sir.
अरे नहीं दिया. उतना इजी क्यों देगा वो. ए ब्लॉक ऑफ मास m प्लेस इनसाइड द बॉक्स. उसमें क्या डायग्राम है. एक बॉक्स के अंदर में एक कैपिटल M मास है. प्लेस इनसाइड द बॉक्स डिसेंड्स वर्टिकली विद एक्सेलरेशन. ये बॉक्स पूरा नीचे आ रहा है. ओके. ए ब्लॉक एक्सर्ट्स ए फोर्स इक्वल टू 1/4 ऑफ द वेट.
So does that mean that the normal
Normal action.
force is equals to
हाँ.
1/4 mg?
1/4 of the weight mg. So normal action acting here mg is acting. No sir.
Sir, what?
What
Sir,
of the
1/4
JEE question?
of the weight.
See what are the language they talked.
Okay,
I given
हाँ.
that one. हाँ
So 3g/4.
देखेंगे.
To be fine.
Sir, and I got 3g/4.
Yes. 3J4 is
So
answer.
they asked this in mains.
हाँ हमारे 2022.
Sir, lucky people, sir.
अरे इजी आए तो इजी बोलते हैं. अभी नेक्स्ट आगे आएगा और ये आपको इंटीग्रेशन सब करना पड़ेगा. दैट टाइम हार्ड बोलेगा.
So then that is very unlucky people, sir.
सी पेपर कभी भी इजी मीडियम हार्ड इसी में चलेगा. ऑलवेज फिजिक्स में तो ऑलवेज ऐसे ही मॉडल में जाएगा. इక हार्ड तो ఒక 2 or 3 क्वेश्चंस जाएगा. दैट्स इट. मिगతా मीडियम में रहेगा एंड इजी मोड में रहेगा. इसी में रहेगा. समटाइम्स इక उन लोग को सम प्रॉब्लम मतलब डेफिनेटली आई वांट टू गिव पेपर हार्ड बोले तो दे विल गो टू मीडियम एंड हार्ड लेवल में. सो दैट्स अनलकी पीपल दैट टाइम पीपल. ओके चलो So 3G 4A. कृषा आया?
Yeah, sir.
ओ आ गया. हमारे कहाँ में बैठ रहे? हाँ चलो नेक्स्ट. तो इक्वेशन मालूम है ना? इक्वेशन क्या है आपको? सिंपली mg minus n is equal to ma, but n is what? 1/4 of the 1/4 of the weight. So n is equal to 1/4 of mg. ये यूज करके सॉल्व करता आ जाएगा. ओके चलो नेक्स्ट क्वेश्चन. हियर m1 इज देयर, m2 इज देयर एंड नीचे जा रहे हैं, ये ऊपर जा रहे हैं. ठीक है, ऐसा दिया है. ही इज टेलिंग acceleration is given as g/8 at the time, then the ratio of the masses is, मतलब m1 is to m2 is how much?
Sir, which
your
one is M1, which one is M2?
This is m1, this is m2.
Okay.
Tell your options. Think 2024 में. If you tell first one answer submissible है बोले तो wrong हो जाएगा. I'm telling you. 4/3, 8/1, 5/3, 9/7.
Sir, what are we supposed to find?
क्वेश्चन नहीं दिख रहा है.
Oh, okay.
m1 is to m2.
Sir, down mass is M1.
This is m2, this is m1.
Okay.
Sir, 9/7.
देखेंगे.
Sir, which mass should we assume bigger?
देखो इधर एक्सेलरेशन नीचे जा रहे बोल के दिया ना, that means this is bigger only.
Okay. So, sir, if I take M2 as bigger, I'll get T1 minus M1G then, right? For the M1.
नहीं जो भी है वो डाल देने का. m1 minus m2 m2 minus m1, which is bigger, that one you have to put. You're using shortcut,
Sir,
right? हाँ.
I got M2 is to M1 as 9:7.
m2 is to m1 as 9:1. आपको कृषा?
Sir, same thing.
हाँ m2 by m1. ओके चलो इसमें डायग्राम में सब टेढ़ा आएगा. So m2 by m1 9/7 is
No,
आंसर.
sir, they said ratio of masses.
हाँ एक्चुअली क्या है, ये उल्टा है. ये नीचे है, ये ऊपर है. ओके सो m1 m2 डायग्राम कैसे दिया मालूम है? द गिवन ऐसा पुली दिया. they given like this only, same
Yeah,
diagram.
sir, answer should be 7/9 if they're asking M1 by M2.
हाँ.
But M2 by M1 will be 9/7.
they given only this one m2. okay but इधर assume करके करना पड़ेगा आपको. they not given any which is greater which is lesser नहीं दिया. ये यही डायग्राम दिया ऐसा. so then आपको assume करके करना पड़ेगा m2 greater है m1 greater बोल के. okay so we got as how much? m2 by m1 you got as 9/7 हाँ कृष्णा? हाँ this is
Yeah.
answer. yeah चलो next one. डायग्राम गलत दिया है थोड़ा. नेक्स्ट. टू 2024 ये भी.
Sir, options?
Sir, from NLM only one question comes.
In every chapter one question.
Only one question.
Every chapter में see how many questions are there in JEE Mains में? Tell me. Total 25 questions, right? 25. How many chapters are there? If you see carefully, first year में 14 chapters, second year में 14 chapters. Nearly 28 chapters are there. 28 में 25 ही आएगा. मतलब generally all chapters they will touch.
Sir, I got the answer. So very easy.
Let them do.
Sir, T1 is
Sir,
wait. Let them tell. I'll give options. 60, 80, 88, 96, 40, 64. हाँ बोलो.
Sir, 40, 64.
40, 64.
Oh, T2 is there. Oh.
40/64.
Yeah, 40/64.
Yes, this is answer. Okay.
ओके सर
क्वेश्चन करेगा और नेक्स्ट क्लास में करेगा
नेक्स्ट क्लास
एक मिनट